Hi students, welcome back again to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Thermal and energy systems. Thermal and energy systems. Mechanical energy, work and power. Heat as energy in transit, energy conservation and conversion, heat engine and efficiency. Case study, internal combustion engine. Case study, electrical power generation. Case study, jet engine. Objective. The keywords: energy, heat, work, and power. Conduction, convection, and radiation. The principle of energy conservation. Heat engine. Efficiency. Two-stroke and four-stroke internal combustion engine, electric power plants, and a jet engine. Objective. At the end of this chapter, you will be able to calculate various energy, heat, work, and power quantities that are encountered in mechanical engineering and express their numerical value in the SI and the USCS system. Describe how heat is transferred from one location to another by the process of conduction, convection, and radiation. Apply the principle of energy conservation for mechanical systems. Explain how heat engine operates and understand the limitation on their efficiency. Outline the basic operation principle behind two-stroke and four-stroke internal combustion engine, electric power plant, and jet engines. Summary. The keywords: several principles behind the thermal and energy systems. Internal combustion engine, electric power plants, and jet aircraft engines. Renewable and non-renewable source. Global energy challenge. Conduction, convection, and radiation. An ideal Carnot cycle. In this chapter, we introduce several principles behind the thermal and energy systems encountered in mechanical engineering. Each technology of internal combustion engine, electrical power plants, and a jet aircraft engine is based on converting heat into work. The innovative production, storage, and the use of energy from renewable and non-renewable sources will also play a significant role in meeting global energy challenges in the coming years. Heat engines are often powered by burning a fuel, and its heating value represents the quantity of heat released during that combustion process. In accordance with the first law, the heat can flow into a material and cause its temperature to rise by amount depending on its specific heat, and the heat can be transformed into mechanical work. We view heat as energy that is in transit through the modes of conduction, convection, and radiation. Mechanical engineers design engines and convert heat into work with a view toward increasing their efficiency. In an ideal Carnot cycle, the efficiency is limited by the temperature at which heat is supplied to the gasoline and released to its environment. Thermal and energy system. Keywords. Up to this point, force in structure and machines, materials and stresses, and fluid engineering. In a nutshell, either consumes or produces power. The practical topic of thermal and energy system. Internal combustion engine, aircraft propulsion, and electric power generation through solar, hydroelectric, fossil fuel, and nuclear technologies. Diesel fuel, rotation of crankshaft, the motion of a vehicle, heating or refrigeration. Up this point, we have explored the first three elements of the mechanical engineering profession: forces in structure and machines, materials and stresses, and fluid engineering. Mechanical engineering was described in a nutshell as the process of developing machinery that either consumes or produces power. With that view, we now turn our attentions to the fourth element of mechanical engineering and the practical topic of thermal and energy system. This field encompasses such hardware as internal combustion engines, aircraft propulsion, and the electrical power generation through solar, hydroelectric, fossil fuel, and nuclear technologies. Although you can either see energy nor hold it in your hand, energy is needed to increase the velocity of an object, stretch it, heat it, and elevate it. In the internal combustion engine, for instance, diesel fuel is burned to release thermal energy. In turn, the engine converts thermal energy into rotation of its crankshaft and ultimately into the motion of a vehicle. Machinery that consumes or produces power often involves process of converting the chemical energy that is stored within the fuel into thermal energy, converting thermal energy into mechanical work and shaft rotation, and moving energy between locations for the purpose of heating or refrigeration. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz. See you next time.